Good morning and happy Monday math day, 4th grade. All right, today's math video focuses on adding multi-digit whole numbers. We're going to make sure that we're using some base 10 knowledge, expanded notation, and of course our standard algorithm up to the 1000s place today. Okay, all right, so first one, I'm going to go ahead and write down the first problem. And without me reading it, I want you to read the problem as it is written. Okay. All right, so we should be reading this as 1036 plus 7675. Did you say it correctly? Good job. Go ahead and give yourself a nice little pat on the back if you did. And if you didn't, let's see if by the end of the video we can get there, okay? All right, so we're going to add these two numbers up, but remembering that when we're adding, there are a couple of steps that we need to follow and some rules to kind of go along with, okay? First thing is that when we're adding or subtracting, we need to start in which place value? And starting in our ones place, tens place, hundreds place, or our thousands place? Our ones place. Good job. So because we're starting in our ones place, we also want to understand that this is called our ones place because these numbers represent 6 ones, 5 ones. Okay? And our next place value is called the tens place because this 3 represents 3 tens, 7 tens. Okay, so sometimes these little squares will actually look like this, but I thought the dot would be faster. All right. And in our hundreds place, we see 0 hundredths and a value of 6 hundredths. And then our thousands place represents 1,000 and 7,000. Okay, I just wanted to go over that breakdown to make sure that you understand that when you are drawing using a visual, you can do it this way, and our ones, tens, hundreds, thousands would just be a really large one of these that represents 10 of these, okay? But then also, going from ones to tens, we are multiplying times 10, okay? Going from tens to 100s is the same thing. We're still multiplying times 10. 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1,000. Okay? So just keeping these in mind, our base 10 blocks tells us that 10 of these ones would give 1 10, would give us this 1 10. Okay? And this 1 10 or rod, 10 of these would fit in, okay, it's not precise, but we understand that 10 of these rods would fit and make up one small cube. I went the wrong way. Small cube, rod, and a flat. Okay, so just a quick review that, let's erase this. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so each of these small cubes represents 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's 10. This represents the number 10. Now, if I were to convert this and I say, oh, I don't want to carry around these 10 small cubes, I want 1 rod. This is equivalent to what this would be. So, okay, not super exact, but that's okay. We understand that each one of these represents one of these. 10 small cubes equals 1 rod. Each one is 1. Each one is 10. Okay? And if we go and we now make, we get 9 more of these. I'm not going to draw all of them. Okay, and if I go all the way across, I'm just going to do a few. No, I want to do them all. Okay, start, not finish. All right, so now all of these equals 100. Okay, so 1 small cube equals, again, 1. 10 small cubes equals 1 rod of 10. And 10 of these rods would give you 1 flat, or 100. Okay, so just understanding where the ones, tens, and hundreds really do add and build onto each other. All right, so now that we have that visual in mind, let's take a look how we can use our standard algorithm, but also for those of us that are still struggling a little bit with regrouping, how when we have a larger number, we have to carry it over and regroup. We're going to look and see how maybe using the expanded notation will help us out. All right. So I'm going to go ahead and transfer 1036. And remember, when I am using expanded notation, I'm going to stretch out that number by its place value. Starting with my greatest, 1 represents what number? 1 is in the thousands place, so this represents 1,000. Keeping that in mind. Okay. 0. Do I have to write a 0? No, because the value is 0, so I'm not going to write 0 hundreds. I'm just going to leave a little bit of space. Next number, 3. 3 represents what? It's in the tens place. 3 tens would give us 30. Good job. And finally, last number, in which place value? 6 ones would give you 6. All right, let's move on to our next number here. 7,665. How you're saying it is exactly how you're going to write it. So, first number you said was 7,000. 7 in the thousands place represents 7,000. Next number, 7,600. 6 in the hundreds place represents 600. 75. 7 in the tens place represents 70. 5 in the ones place represents 5. All right, so I can use my standard algorithm, which means just to add it right here, right now, or for a little bit more support, I can use my expanded notation to add it up there. All right, so I'm going to go ahead and start from left to right. I'm going to use my standard algorithm and then work into my expanded notation addition form. Okay, I'm going to go ahead and make sure I'm set up for that. All right. Using my standard algorithm, I need to always, of course, start with my ones place. 6 plus 5 is 11, but I can't write an 11 here. There's only room for one digit under my ones place. Okay, what we've been doing before was writing the number so we know what it is, okay? Starting with the smallest place value in the ones place. 1 goes here, the other one goes next door because we're regrouping. Okay, remember going back to that visual when we have more than 10 of the small cubes, 1 has to get carried over into our tens place to exchange it out for that rod. Okay, so we have 1 small cube remaining, and this is our 1 rod. So now we're going to add the rest. 3 plus 7 is 10. 10 plus 1 is 11. Same number. So I can't write an 11 here again because there's only one place, one space for that number. So I'm going to write that smallest number. When I say smallest number, it's the number in the smallest place value. So there goes that 1 and regroup. Okay, same as if I have 11 rods, excuse me. If I have 11 rods, 10 of those can change because 10 tens will give you 100. That's why 1 is now in the hundreds place. And that 1 from the 11 stays here in our tens group, okay? 0 plus 6 is 6. 6 plus 1 is 7. And finally, our thousands place. 1 plus 7 is 8. Don't forget that comma. All right, so when you're working on any kind of math, whatever kind of math it is, you need to really go ahead and really check your work. So because we went from this top row to the bottom row, a good way to check it using addition is just go in a different order. So let's start with the 5 and then end with the 6. 5 plus 6 is 11. Yep, same number now. 7 plus 3 is 10. 10 plus 1 is 11 again. Yep. 6 plus 0 is 6. 6 plus 1 is 7. Here we go. 7 plus 1 is 8. All right, so that's just me checking my work really quickly, making sure my answer is correct and complete. All right, So now that I filled out my standard algorithm, I want to see what it looks like when I'm going to add using my expanded notation. So the only difference is that I've separated the numbers by its place value, okay? But the same strategy is being applied, okay? So 6 plus 5 is, yep, still 11. Again, the 1 is in the ones place. This is our tens place. One group of 10, because 10 plus 1 is 11, is going to go over here. Because I'm going to take this one over here, I'm going to change this 3 to a 4. Because I'm taking that one group of 10, I'm adding it to this group. That's what we're doing here. I'm taking 10 and I'm adding it to my tens place. Now, 40 plus 70 is, how many of you said 11D? I thought that too. All right, but 11D is not a real number. So it's 11. So how am I going to write 11? Okay, in here. So yep, same thing. I'm going to write this one right here. And, excuse me, okay. All right, so I'm looking back at this and realizing I could have done this two different ways. So I know that I'm taking one group of 10 and I can add it to my 30, making it 40, or with my 30, I can add my 10 up top so that I understand what's coming over here and why. Okay? So I'm going to go ahead and do it this way just to make sure that you know what the original problem is and how many I'm bringing over from my ones place. So 10 plus 1 would give us that 11. Okay? All right, so when I add 30 plus 70, which is 100, and 110 now, remember this is our tens place. I can't go any higher than that. So this is our hundreds place. So because I have 110, that 10 stays here, that 100 now can go over into our hundreds place. Okay, because once we cross over from 2 digits to 3 digits, it now needs to get carried over and regrouped. Okay, so just checking, 70 plus 30 plus 10 is 110. 100 goes here to regroup. 10 stays here because it is in that tens family. 100 plus 600 would give us 700. If you're getting kind of squished with your numbers, you can continue to write the addition sign here because it's still expanded notation. Okay, and finally 1000 plus 7000 is, just because it's a larger number doesn't mean it's any harder, okay? It's all lined up, commas, same amount of numbers. You're only adding those numbers, those whole numbers that are non-zeros. 1 plus 7 is 8. They both have the same amount of zeros at the end, and that's 8,000. All right, so now we're going to take a look at how we can change this expanded notation form of the word or number into 8,711, because it reads 8,700, 10 plus 1, giving you that 11, okay? All right, so this is some good review. You don't have to use expanded notation, but I want you to practice whichever method that is the best and easiest for you, okay? Standard algorithm is the goal, but you have now different ways to get there, okay? Using our visuals, our base 10 blocks, but also expanded notation, the actual process of breaking down by place value and how we get there. If you need to pause or rewind this video at any point in time, you may do so. That is why the videos are being made for you. Do your best and have fun with this. I'm going to now give you a couple of assignment problems on this video, but as well as on Canvas where you can find it, okay? So again, Mondays and Tuesdays for math, you're going to only get 2 problems. Problem number 1. I'm not going to read it. I want you to try it before I say it. All right, what does that problem read? 1,934 plus 4,829. No decimals, no and. Okay, and number 2. I'm going to write this one horizontally. 241 plus 376 plus 1,457. All right, this is your assignment for today. Add these two particular problems up using standard algorithm, expanded notation, draw a visual to go along with your work, and please check your work. If you have any questions, please ask, and have fun with the math, okay? If you have any questions, ask. I already said that. Have a great day, and see you again later. All right.